Okay, so we do have other terms also for descriptive statistics. So we have the 95 confidence interval for mean lower bound and the 95% confidence interval for the mean upper bound. So you may read the definitions of these guys, but I just want to give emphasis on the 5% trim mean. Now, the 5% trim mean is being defined as the mean that will be obtained if the lower and upper 5% values of the variable were deleted. And nay nakabutang diri guys, so I really put emphasis on this part. It says that if the value of the 5% trim mean is very different from the mean, this indicates there are some outliers. However, you cannot assume that all outliers have been removed from the tree mid. So again, guys, you can actually detect, okay, not just through graph, but also through the values for descriptive statistics in relation to the presence of outliers or extreme observation. So you can actually compare the result of your mean to your 5% trim mean. Now, if the values are way very far from each other, there is a big difference, okay? When it comes to the values of your 5% trim mean and your mean, it indicates the presence of outliers. So usually, guys, if the difference of the value exceeds 10%, okay, or greater, that will give you the idea that there are indeed outliers in your sample. Okay, so again, if the values of your 5% trim mean and your mean is very far from each other, it indicates the presence of outliers. Then, of course, we also have the standard error of the mean. It measures the dispersion of the sample means around the population mean. Okay, standard error mean is actually similar ang iyang purpose. Okay, it also measures for dispersion, but the most commonly used is the standard deviation compared to your standard error of the mean. And of course, you have also your percentiles, right? So percentile, so very helpful, especially if you want to know the distribution, if we have a lot of factors to consider, such as gender, male and female, very effective, okay, ang atong percentage, okay, to know the breakdown of our sample population. Okay, so this is what I'm telling you guys a while ago, that for our percentile, it is consists of 4 quartiles, of course, from quartile 1 to quartile 2. Okay, so remember lang guys that your quartile 1 separates the first and second quarter. Quartile 2 separates the second and the third quarter, and quartile 3 separates the third and the fourth quartile. Then we have the value of your interquartile range. Very easy lang. We just need to get the difference between the quartile 1 and quartile 3 value for our interquartile range. Then we also have your weighted average and Tukey hinges, guys. Tukey hinges, we will actually explain more of this when we talk about ANOVA and chi-square. I just want you to remember, guys, that for weighted average, guys, the values are not are sorry, the values are interpolated. Mean to say, there are some modifications when it comes to computing the values for the weighted average. And usually, some of the values are fractional, okay, which is the result of how they are calculated. Then you also have the Tukey's hinges. This refers to the first, the second, and the third quartile result. But I want you to remember that unlike weighted average, the values are not interpolated. Okay, they are approximations or estimates that can be obtained with little calculation. So we will talk about two case hinges, more of it uh, in our upcoming activity. Then for the percentile, okay, we have actually three subcategories of your percentile. We have the 25 percentile or the 25% percentile. This is known to be also our first quartile. Then you also have your 50 or the 50% percentile. This is known to be the median value nato, okay, which is part of the measurement of the central tendency. And what is nice with the median, guys, is that it is less sensitive than the mean whenever we have extreme observations. Then we also have the 75% percentile, which is known to be the third quartile. So what is also nice, guys, with the descriptive statistics feature in SPSS is that the SPSS will also provide you with the table for extreme value. So in this particular table, you can determine the highest and the lowest values of our data set. Okay, and the number of cases, okay, and its respective value. Okay, so let's go now to the different uh, uh, tools for presentations for SPSS. So first is we have your histogram. Okay, I think I've mentioned this to you guys in the previous discussion that the histogram is indeed very useful, especially for interval values or ratio values. So whenever we want to present our data in a way that we can distinguish the frequency or the interval of the data, the best presentation or the best tool to use is your histogram. So like this example, guys, weight in kilograms. So very easy to determine the values for the frequency, right? So how many of the sampled population have the weight of 75? So based on this histogram result, it will tell you that there are four respondents, okay, who weight 75 kilograms, okay, or has a body weight of 75 kilograms. Okay, so I have also here another tool for the presentation of data, guys. We have the stem and leaf plot. So stem and leaf plot is another way to present your data, okay, the frequency of your data, but it is actually much older siyam na tool for presentation compared to your histogram. So very easy lang to interpret the stem and leaf plot. So we have two parts, of course, the stem and the leaf. So for the stem, guys, the values here are being placed in tens, or we are using the tens place value here. For the leaf, we are actually using the ones place value here. Then for the interpretation, very easy lang. Just look for the frequency, right? For this particular example. So this is in relation to the scores, okay, writing scores for the particular respondent. So upon examining the stem, we have here the first stem, that's 3. Okay, it will actually give you the result that the score is indeed 31, right? So 3, which is in tens place, is placed in the stem, and 1 is being placed on the leaf. So the score is 31. Now look at the frequency, guys. Look at the frequency. So it will tell you that for the leaf, there are 4 ones, okay? Meaning to say that there are 4 respondents who got the score of 31. Okay, so 4 respondents got the score of 31. On the other hand, kindly go to the fifth stem. Okay, so here you can see that there's only 1 8 and the rest is 9. right? The rest is 9. So it will actually give you the idea that there's only one respondent who got the score of 38, and the rest is already 9. Okay? That is why, guys, the frequency here is 6. Okay. So that is how you can actually interpret, guys, the stem and leaf plot model. So it's also similar to your histogram, okay? But here, it's being arranged, the numbers are being arranged with the help of the stem and leaf. So in the stem, you have your tens place, and the leaf, it's your ones place. Okay, then we also have, guys, the box and whisker plot. So um, what is unique, guys, when with your box and whisker plots, unlike any other graph, is the ability to present or to distinguish our quartiles, our three quartiles. We have quartile 1, quartile 2, and of course quartile 3, which is also plotted here in our box plot. Okay, so the main foundation of the box are your three quartiles. And we also in the box and whisker plot, we also have the minimum value and the maximum value that is being plotted. So this is how you can interpret the box plot, guys. So for letter A, this represents the maximum score. Letter B, it's your third quartile value. Letter C is your second quartile value, or the median value, or the 50th percentile. Letter D is the first quartile value, or the 25th percentile. And for your letter E is the minimum value. So also, guys, if whenever there are plots that go beyond the maximum value, and if there are values or plots also that go beyond the minimum value, this is considered now to be your outlier. So try to observe or examine your box plot, guys. So if there are values that go beyond our maximum and minimum results or value, these are now your outliers. By the way, guys, this part of the box plot, okay, Kanisha, is actually called your whiskers. Okay, whiskers na siya. Okay, then of course, we have the frequency table. Okay, so first we have the frequency column. It indicates how many observations, okay, how many cases fell into that given variable or category. Then we also have the percent column. It indicates the percentage of observations in that category out of all observation. Okay, so that's the percent column. Then we also have the valid percent column. It displays the percentage of the observations in that category out of the total number of non-missing responses. Okay, that's for valid percent column. And for the cumulative percent column, it's the total percentage of the sample that has been accounted for up to the row. So it can be computed, guys, by adding all the numbers in the valid percent column above the row. Okay, guys. So lastly is how to interpret your data. So, di ba you have your output, guys? So, I will give you more time pa to do the interpretation, since I know you have a lot of variables. There are 4 variables that you need to interpret. But in your interpretation, I want all of these properties to be seen, okay, in your output. So first and foremost is for the interpretation, you need to describe the size of the sample, then of course the center of the data, and of course describe the spread of your data and assess the shape and spread of your data, or the shape and the peakness, okay, of your data. Okay, so for your sample, usually samples should have at least 20 observations. Okay, so usually use n, diba, to know how many observations are in your sample. And for statistical analysis, the requirement should be at least 20. Okay, but whenever we are using histogram, guys, for data presentation, it is recommended that you have at least 50 observations. So try to examine for the size of your sample, guys, in your variables. So is it adequate lang ba? Okay, is it inadequate or lacking ba ang sample, or does all of the respondents answer, okay, or give their data? Okay, so you try to evaluate all of this under the description of the size of your sample. Okay, so the next thing also that should be in your interpretation, guys, is the description, or to describe the center of your data. So we have actually the three measurements of central tendency, right? The mean, the median, and the mode. Okay, so these are very helpful po whenever we want to assess how is our data being positioned. So is it perfectly distributed ba siya, bell-shaped ba siya, or the position ba is going to the left, or the position is going to the right. Okay, so you can actually detect this by getting the results or the value for your mean and the median. Because if the mean and the median is very far, or the values is far from each other, or inconsistent ang value, that will give you an indication that the distribution is not normally, or the population is not normally distributed. Okay, so di ba remember in our discussion that if the mean is larger than the median, it is positively skewed. Okay, mean is larger than the median, positively skewed, meaning to say it's going, okay, it shift, or the positioning is going to the right. But if the mean is lesser or smaller than the median, it is negatively skewed, or the positioning is going to, or it's shifted to the left. Okay, so this can also be very, very helpful, guys, and this should also be in your interpretation. So again, compare and contrast the mean and the median for all your four variables. And of course, the next thing also is the spread of your data. So the main component, or the main parameter that we'll be using to assess the spread of your data is our standard deviation. So usually look also the value of your standard deviation and the mean. Okay, so use the standard deviation to determine how the spread, okay, how your data is spread, okay, from the mean. Because if there is also a greater difference between the standard deviation value and the mean, it indicates also a high spread of your data. So it indicates here that a higher standard deviation value from the mean indicates greater spread of your data. So this should also be put in your interpretation. Okay, and the last thing that you need to interpret, or you need to assess, guys, is the shape and the height, okay, or the spread, also the spread of your data distribution. So again, we have two parameters for this, the skewness and kurtosis. So skewness used to measure the spread, okay, of your data. Okay, is it positively skewed or negatively skewed? And by the way, guys, to help you to understand, or to help you to guide you in the interpretation of your skewness, you may also want to check the histogram, okay, value, the histogram presentation of the different variables, because through the histogram, it will also give you the idea whether the direction is on the left, or it's on the right, or it's normally distributed siya, with the help of your histogram and also your box plot. Okay, and for the peakness, okay, know whether it's really too high, or it's a too peak or too low, then you have to evaluate it with your kurtosis value. Okay, then don't forget also to provide interpretations for your graph. Okay, so your histogram, your box plot, and also your stem and leaf plot. So don't worry, I'll give you more time, okay, for the submission of this particular output. So you will submit this na after our midterm exam. Okay, so if you have any questions, guys, in relation to this pre-recorded video, don't hesitate to message me or to contact me, guys. So I hope now it's clear to you na how to interpret your data. Just use these four parameters in your interpretation per variable. Okay, do not interpret it per gender, but as a whole na per variable. So thank you very, very much, guys.